Alrighty guys, film in 5.2 to 5.4, right triangle trig review for your test. Alright, getting into it here. Okay, so it can be hard to tell from the video, but this is a triangle with a side of 4, another side of 3. Again, these being our two short sides, kind of implied. It should be marked here, but this is a 90-degree angle. Okay, so we know that this side across from the 90-degree angle is my hypotenuse of that triangle, which means it is longer than 3 and 4. Here's my theta angle, right? So when I'm thinking about my trig ratios that I'm going to find here, it's all from that angle's perspective, right? So the opposite side, the adjacent side, has to do with where this theta is, right? So it's the opposite of that angle and adjacent to that angle, right? Now calculating this third side, again, I need to use Pythagorean theorem. 3 squared plus 4 squared equals c squared, c being my hypotenuse, my missing side. So 3 squared is 9, 4 squared is 20. Nope, I'm thinking ahead here. When they add them, it's going to get 25. 4 squared is 16, 9 plus 16, 25. And then so c squared is 25. We take the square root, c equals 5, positive 5 for that triangle hypotenuse, right? So there's my hypotenuse. And again, so when I'm thinking about putting together my trig ratios, right, I'm remembering my SOHCAHTOA. So sine is opposite over hypotenuse as a ratio, right? CAH, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So that is our acronym to help us remember. So then, just remembering that, right? So my opposite side, this angle theta is 3. My adjacent side to that angle is 4. And my hypotenuse is 5. So just putting these ratios together based on that. So opposite side 3, hypotenuse 5. Adjacent side over hypotenuse, so adjacent side 4, hypotenuse 5. And then opposite over adjacent, opposite side 3, adjacent side 4. And then again, we have our 3 reciprocal trig functions there, cosecant, secant, and cotangent. Again, corresponding with the original trig function that they're across from there. So it's just the reciprocal. So it would be hypotenuse over opposite, hypotenuse over adjacent, and adjacent over opposite, right? But we can just flip the numbers. 5 over 3, 5 over 4, and 4 over 3 would be those reciprocal ratios. All right, there is number 1. Number 2, so we are given these two triangles. Again, can be hard to see, so I'll make them a little bit bigger. And again, so it's giving us the trig function and an angle to focus on, right? So for this 30-degree angle, right? So we locate the angle, 30 degrees. So we think sine, again, sine opposite over hypotenuse, right? So from the perspective of this 30-degree angle, the side opposite that would be this shorter side 1, and the hypotenuse is this 2. So the sine of 30 is being 1/2. Okay, cosine of 45. So again, I'm thinking there's no 45-degree angle in here, so I look over at this one. So 45 degrees, right, would be any cosine adjacent over hypotenuse. You can look at either 45-degree angle, and both of those, right, have these two equal sides adjacent to them, right? So 1 over hypotenuse, square root of 2. And again, typically we would rationalize that denominator, but again, that you will not lose points if you don't do that on the test that we will take. That is not the skill we are testing on. And then tangent of 60. So again, we go to our 60-degree angle, and so we're thinking for tangent opposite over adjacent, right? So opposite side of that 60-degree angle is square root of 3. Adjacent side is 1. So square root of 3 over 1, which just is equal to the square root of 3. So there is those. And then we got the reciprocal functions. Again, what can help with this is just flipping around these 3, kind of putting these together. So this is hypotenuse over opposite, hypotenuse over adjacent, adjacent over opposite. Just kind of taking the SOHCAHTOA letters. Cosecant, 45. Okay, so again, either one. I'm thinking hypotenuse over opposite. So again, like either 45-degree angle would give you the same result, but like hypotenuse is this, the opposite side, this angle would be this 1. So you could say square root of 2 over 1, which is just square root of 2. All right, and then secant, 60, hypotenuse over adjacent, right? So hypotenuse here is 2. Adjacent side, that's 60-degree angle. Again, we know it's not the opposite side, so it has to be the other short side, this one. So it would just be 2 over 1, which is just 2. Okay, then lastly, cotangent of 30. So cotangent, adjacent over opposite of this 30-degree angle. So adjacent square root of 3, opposite 1. So square root of 3 over 1, just being square root of 3. All right, so just some simple ones labeling our trig functions. Moving on down here. Okay, so find the reference angle. Again, the key for our reference angle. Remember our definition. Our reference angle is our positive acute angle. So reference angles are always positive. They're always acute, okay, meaning less than 90 degrees. So again, just kind of an example, if I was graphing a 135-degree angle, right? We can look in our unit circle too, but just kind of remembering the basics of this. My initial side here, my terminal side would take me beyond 90 here to 135, okay? So that would be my regular theta, right? That's my angle measure, but my measure of my reference angle would be the shortest distance I can go from my terminal side to the x-axis. It doesn't necessarily have to go back the way it came, just the shortest distance between that and the x-axis. And again, there always should be an acute angle distance, unless it's one of those quadrantal angles that we talked about. But yeah, there should always be an acute angle that I can go to get from that terminal side to the x-axis. So here, we think about this, right? We can do 180 minus 135 to get 45. So 45. So we have our theta apostrophe, or we say theta prime, to find my reference angle. Okay, so that's just a quick refresher on a reference angle. So we think about these, and again, we can really just kind of, we can graph these, kind of sketch a little graph if we want, but just like with number 2, 41-degree angle. So just picturing that, 41 degrees would kind of go up, would stay in my first quadrant here. And so if it's already an acute angle, that itself is just the reference angle, right? Because I can just go right back the way I came because I only went 41 degrees from that initial side. Just go right back there, and so that would be my reference angle. Okay. Next one, 435 degrees. So this one, just again, kind of picturing this, kind of thinking a full rotation, right? Remember, full rotation is 360 degrees. So I can account for that by doing 435 minus 360 would give me 75, okay? Which means it's going to go full rotation plus 75 extra degrees beyond that. So thinking about that, right? I can go there, right? That's about what it would look like. But the key is that, again, I'm thinking, how far would it go from where this terminal side ends up back to my x-axis? And so that would be, in this one, that extra 75 degrees that I went, right? And so that would be my reference angle here, 75 degrees. Okay. And now lastly, again, nobody really enjoys these, but we have our radians, right? Right, and just a reminder, we do have our unit circle here, guys. And so again, if we're looking 3 pi over 4 for this problem, so we can see that would be equivalent to a 135-degree angle, okay? And so that can help us, too, to kind of nail this down. But again, just remembering, too, in terms of radians, right? Hopefully we can graph it when it's in radians, too. So 3 pi over 4, that's actually the exact example I did up here, right? So thankfully we can just use that. So 135 or 3 pi over 4 takes me to about there. We know the answer here is 45 because it's, again, equivalent to a 135-degree angle. Okay, so now moving to the bottom here, evaluating these values of each trig function, okay? So cosine of 570. So this is where we definitely need our unit circle. But cosine of 570, okay? So again, the first thing I want to look at here is my angle. And so I want to locate that angle and see specifically what the coordinates are, right? Because we talked about this, how the cosine, when it asks for the cosine of a specific angle, that is going to relate to its x coordinate, right? So each of these points have an x and a y coordinate associated with them. And so cosine associates with x, sine associates with y, right? So it asks for sine, we're looking at the y coordinate. And then if it asks for tangent, that's just y over x, right? So then think about a 570-degree angle. Okay, our problem here is that our unit circle only goes up to 360 degrees. So again, we talked about too, when we're thinking about this, like 570 is too big. I can find a coterminal angle that would be kind of end up at the same place. Again, just kind of picturing these. Again, a 570-degree angle would kind of go a full rotation, and then it would go a bunch extra. Okay, so I kind of want to get rid of that full, like that extra rotation that it would have gone, and just say, okay, what was just that little second go around? How far did it get there? And so where it ended up here and where it ends up here would actually be the exact same thing, and I can use the coordinates of this to help me find the coordinates of this, because again, that ends up in the same place. So I can do 570 minus 360 to get me 210. And so 210, so cosine of 570 is going to be equivalent to cosine of 210, and 210 is on my unit circle, right? So I really want it in that 0 to 360 area to know, to be able to refer to the unit circle to find my answer, okay? But once I know that, so cosine of 210, right? So I go to 210, right, on my unit circle. I go here, and again, the x coordinate for my cosine, negative square root of 3 over 2, okay, would be that cosine value, right? So negative square root of 3 over 2 is my answer. That's all I need to do. Okay, cool. All right, so now number 6, so tangent of 5 pi over 3. So again, I worry that kids get fearful when they see the fraction and the radians. It can be more confusing because it's a lot easier to understand angles when they're in degrees, but don't be intimidated, right? Because we do have radians also on my unit circle, okay? And specifically too, we have it up until 2 pi radians, okay? So from 0 to 2 pi radians, we have that on my unit circle. And so we think about it as a fraction 5 over 3, that if I did 5 divided by 3, that would be less than 2, which means I should be able to find 5 pi over 3 on my unit circle, and I can find it right here. You see 5 pi over 3, right, equates to a 300-degree angle, okay? And just let's say you didn't think of that, or if it was hard to find or it wasn't right on your unit circle, you can always convert it to degrees by doing times by 180 over pi, get it in degrees. That can be easier. But we already found it on my unit circle, so let's just move forward that way. So 5 pi over 3, okay. And so there's my coordinates for that. And again, it's asking for tangent of that angle, okay, which means I need to do y over x. So the y coordinate over the x coordinate, okay. And what the deal is with this too, again, we said that we are going to just ignore those denominators. And so of 5 pi over 3, so my numerator of my y coordinate is negative square root of 3. The numerator of my x coordinate is 1. Okay, so I can just write in terms of y over x, I can write negative square root of 3 over 1, and so that would just equate to negative square root of 3. Okay, awesome. And then lastly here we got secant of 660, so I can minus 360. Again, I know that's too big. That's not going to be on my unit circle because it's over 360. So when you notice that, you just go right into this, subtract 360, and I'm going to be looking at another 300-degree angle, right? That's where my last one was, just in radians, right? And so I can go back to that. I'm familiar with my coordinates of that angle already. But again, secant. So when it's one of these reciprocal trig functions, I have to think, okay, which trig function does that coordinate with? Okay, and secant corresponds with cosine. So what can help me is to find cosine of my 300-degree angle and then just take the reciprocal of that answer, right? Because that's what the secant would end up being. So again, cosine corresponds with the x value. So when I look at this, right, my x value of my 300-degree angle is 1/2. So if the cosine is 1/2, right, the secant of 300-degree angle would be equal to 2 over 1, the reciprocal of that. Okay. And so that's going to be my answer. 2 over 1 or just 2. All right, guys, looking at page 2 here, we got numbers 8 and 9, where we are finding the side labeled with a lowercase letter, again, with my small font. Hard to see in the video, so that is A, the side here that I'm looking for, okay? And what I know is that this angle inside is 65. I also know this side's 90 degrees because I labeled it right that time. And then I know that this side is a length of 15, okay? So what we have to do is, again, our goal is to find this A. And so what we have to do is get oriented for a second, kind of think about, okay, what do I know? And then what trig function can I use to find this missing side? Okay. And so what I do know is that this side length is 15. And I think, okay, what side is that? Again, it's across from my right angle, which makes it the hypotenuse. Okay. So I know the hypotenuse. Okay. And what else I know? Obviously, I know my 90-degree angle, but I really don't like, all these triangles that we're dealing with are 90-degree right triangles. So what helps is to know another angle, right? And I do know one. I know this is 65. Okay. And so I'm thinking, again, kind of from the perspective of this angle, right? My hypotenuse always is my hypotenuse. But is this side I'm trying to find the opposite or the adjacent side to that angle, right? Opposite means it's not kind of coming together to form that angle. It's kind of across the triangle from it. And this, yeah, so this A side would be the opposite side of this 65-degree angle that I know. Okay. And the reason that's important to find is that that's going to determine what trig function I use. Okay. So I want to think here about the trig function that involves opposite and hypotenuse, which in this case would be sine. So that's where I start. That's where I start. I get oriented. I think about, okay, what is this side to this angle that I know? Like, what is it in relationship to that? And then I pick my correct trig function from there. And then, yeah, I kind of fill in, right? So the kind of the standard equation for sine is sine of an angle is the opposite side over the hypotenuse. And again, I fill in what I know here. Okay, so what I know is that I know the angle is 65. So sine of a 65-degree angle is going to be the length of the opposite side, again, which I don't know, so I can fill that in as A. And then I can say the length of the hypotenuse, which I do know, is 15. Okay. So now I just have kind of an algebra equation here. Sine of 65 equals A over 15. Okay. And so I think of just algebraically, how can I get that A by itself? And so I need to cancel out this 15 in the denominator by multiplying both sides by it. Okay. And so if I do that, that will cancel out, and I would have A equals 15 times sine 65. Okay. And right here, right, this is all calculator right here. I can go right into my calculator and I can do 15 times sine 65. And so now I can just do 15 times sine, right? So my sine button right here above my numbers, sine of 65. I get an answer of 13.59, or I can round that to 13.6, because again, the directions say round to the nearest tenth. So what does that mean? What did I just find? I just found the length of this mystery side right here, which is 13.6 inches. Okay. And so I know that A is 13.6 inches. All right, with that, looking at number 9 as well. Okay, so actually a pretty similar situation. Right triangle, I know this bottom angle here is 42 degrees, okay? And so I think about what sides do I know? Okay, for this one, I know this 6-foot side, and what am I trying to find? I'm trying to find this side, which is the hypotenuse. Again, I know it's the hypotenuse right across from my right angle. And so then I think, okay, I'm trying to find my hypotenuse. That's my mystery side. Okay, I know this angle, and then I think about, again, what this side right here. Where is this side in relation to this angle? And I would say, right, it's not the opposite side. It's not across the triangle from that, right? This would be the opposite side. But this side is the adjacent, right? So that's my adjacent side to this angle. Again, it's all about where is that angle that we know, okay? And what is this side in relation to that? So now I think, okay, adjacent and hypotenuse, what trig function is involved there? And that would be cosine. Cosine involves adjacent and hypotenuse. So I set up a similar equation, right? Cosine of an angle is equal to the adjacent over the hypotenuse, okay? So again, I substitute in what I know. Cosine of 42 equals 6. I know my adjacent side. I don't know my hypotenuse. So you can leave that as H, or you can put it in a C or whatever, okay? So now I'm looking at this and I think, okay, this one's a little bit more complicated because C is my variables in my denominator of my fraction, okay? So a lot of kids here try to multiply by 6 because that's what we do in this situation. When my number's in the bottom and my variable's on top, you can do that, okay? That's a good thing to do. And you can multiply by 6, but it's not going to get this C out of the denominator, okay? That variable is going to stay down there until I multiply by it. And that's really the most efficient thing to do in this case is I have to do it at some point. So let's just multiply by C to both sides and get that variable out of the denominator. And so it would just be C times cosine 42 equals 6. And again, I want this variable by itself. And I know this cosine of 42 is just going to give me some decimal answer, right? So that's just a number that I can divide. So C ends up being 6 over cosine 42. And again, once I get this variable by itself, then that's all calculator, okay? So I can go in, I can do 6. Again, if you have a fancy calculator, definitely use that fraction template that you can use with alpha y equals, but this clearly is an old one, with the one that I used in high school back 50 years ago. Just kidding, not that old. But 8.07, or if I round that up, 8.1. And again, what did I just found? I found my hypotenuse, okay? 8.1, let's keep the units consistent, 8.1 feet, 8.1 feet. And again, quick mental check. Does that answer make sense? Yeah, it's not too much bigger than the side that I know, but it's supposed to be bigger than the side I know because it's the hypotenuse. And again, a hypotenuse is always the longest. Awesome. So we are in good shape for those two. Moving on down, number 10. Okay, so find angle theta, round to the nearest tenth. Okay, so now the different situation. Okay, think about this. I knew my angle in one side length here, and my job was to find the other side length. In this situation, I know two side lengths, but I don't know any of the angles inside. Okay. It's going to be a similar start. I want to get oriented with my triangle here. Think about, what do I know? What do I need to find? I need to find my angle. But again, what's really important is I think about where are these sides in relation to this angle? And again, my hypotenuse is always going to be the hypotenuse, regardless of the angle I'm looking at. But again, these opposite and adjacent sides can change depending on what angle I'm focusing on. So from this bottom angle, this 18 centimeter side is going to be adjacent to that. Again, when it's not the side across from the triangle from that. The adjacent side is part of one of the two sides that comes together to form your theta angle. Okay, so that's how we know it's adjacent. And so what does that look like, right? Similar situation to up here where I knew I was focusing on adjacent and hypotenuse. Same thing. So cosine is going to be a good trig function to use here. Okay. So cosine theta, set up my my default equation. Not opposite, adjacent over hypotenuse. All right, and then again from here, I substitute in what I know. So cosine, I don't know my angle, so that's going to stay theta, but I know my adjacent side's 18. I know my hypotenuse is 20, so 18 over 20. Now, different situation, right? My variable is not over here. What I'm solving for, this theta is actually my variable because that's what I don't know, and that's what I need to solve for. And so you have to think about, like, okay, I need to almost cancel out this cosine, or get that to the other side so that I can get theta by itself. Okay. And some kids try to divide by cosine, right? Because it's almost like it's next to it, so we can divide by it. That's not what we do, okay? So cosine is kind of its own operation or its own function. And so we have to do the opposite or the inverse of cosine, okay? And if you remember on your calculator, inverse cosine is represented with just this cos -1, okay? And so when we do that, we can almost do that to both sides, and that will kind of cancel out this cosine. But over here will be inverse cosine of the fraction. And then that kind of, when I do that to both sides, it kind of cancels here, and then it's the inverse cosine of that fraction there. Okay, so that's what I want to do in my calculator, okay? And so I go for that second cosine, and then my fraction, 18 divided by 20. Okay, and so I get 25.8. Now round to the nearest tenth, so we can just leave it there. So theta equals 25.8. And again, what did I find? Did I find a side length? No, I found an angle, right? So that wouldn't be 25 centimeters, that would be 25 degrees. That's saying that's the measure of that angle, 25.8 degrees. Okay, so that is what I'm dealing with there. Perfect. Number 11. Find the values of 6 trig ratios for the angle theta that terminates at the point -1, 3. Okay. So let's just think about that first. Okay. And well, I guess the rest of it. Draw a triangle in the correct quadrant, label the lengths of the sides, and the coordinates of the point on the terminal side clearly show theta and theta prime, our reference angle, on the diagram. Okay, so here's our diagram, this graph. Okay. So let's just think about this for a second. Okay, so -1, 3. Where is that point? That point is going to be -1, +3 up here. Okay, and again, you can kind of draw your tick marks, 1, 1, 2, 3, kind of help with that, right? So that's just a point. So I just start just like you would do before in math classes. You plot a point, and there it is. Okay. But what I want to do too, because this is trig, studying these points as kind of triangles and angles, I want to make a triangle out of this, right? So again, thinking of this as an angle, right? almost like your terminal side of an angle that we graphed, right? So we can think it went from the initial side on the positive end of the x-axis to there, so that's my terminal side. And then again, making it a triangle too, that comes, you always drop this down to the x-axis, okay? I know it would be shorter to just connect it over here to the y-axis, but you always go down to the x. We talked about that. Okay. And so again, we think about, what do I need to know in order to put together my 6 trig functions? And I need to know my lengths of my sides, okay? So again, I have -1, 3 is my point, okay? But also, we have our, those are the lengths of my sides. You think about this. If this is at 0 on the x and on the y, right? So like, think about this. It goes from here to here, right? That's the length of this bottom end of the triangle. And you think about, like, on a graph, how many units long is that? And so that would be 1 unit long, okay? The side length going from 0 to -1, that's 1 unit long. But I do write it as -1, again, because on my graph, now I have to worry about, like, my coordinates and my points, okay? So yes, while the side length of that triangle is 1, I'm going to write -1 so that I can put that correctly into my trig functions. And then my y, this long side, is 3, and that's how long this longer side is. 3 units, right? Going from 0 to 3 on the y-axis, okay? So that is what I have there, okay? And so then with that information, again, think about, I know 2 lengths of my sides of my triangle, and so once I know 2 lengths of my sides, I can use my Pythagorean theorem, right? A squared plus b squared equals c squared to find my third side, okay? And so I just substitute in these values, -1 squared plus 3 squared equals c squared, right? -1 squared is 1, 3 squared is 9, and then 1 plus 9 is 10. And then the square root, so c equals square root of 10, okay? And in fact, something else too, we called this not only the c, the hypotenuse, we also called it the radius. So it's going to be more proper to write this as r equals square root of 10. Because again, thinking about this too, another way to think of this, and you wouldn't have to draw this on your diagrams, but just, again, where does the r come from? We can think of this almost as like a circle too, right? Where, yeah, like this, if we think of this like our, just like our unit circle in our graph, like this would be the radius from the middle to the outer edge of a circle. That's also a way that we could think of this on a graph, okay? So that's where the radius part comes from. Anyway, okay. So I know that this side is square root of 10. And yes, that radius is always going to be positive. Okay, so that's a good way to check your answer too. All right. So I have my whole diagram. Okay. Let's make sure we read the directions, got everything. Label the lengths of the sides. Boom. Coordinates of a point on the side. Boom. Got it. Got it. Clearly show theta and theta prime. Okay, let's do that. So this is theta, kind of represented that. Again, theta, original angle, always begins on this initial side, my x-axis. So this would be theta. And I also specified in class that you should find theta and theta prime. Let's make sure we do that too. And we're going to go even in reverse order here. It's going to be easier to find theta prime first and then work backwards to find theta. Draw the triangle, boom. And then, sorry, I'm losing track of where I'm at. And then where is theta prime on my diagram? That is kind of this reference angle or this initial side on my, in my triangle. So that reference angle, again, to kind of think of too, just the shortest distance from this side, terminal side, to the x-axis. So it serves that purpose and also serves the purpose of being that angle in my triangle. Okay, so theta from the x-axis to that terminal side, and then your reference angle from the terminal side to the x-axis, shortest distance you can go should be an acute angle, right? Okay, boom, did that. All right, so all I have left to do now is find the 6 trig values and find the angles, okay? Now that I know all my side lengths, filling these in is going to be pretty easy, right? And again, to be able to fill these in, it's going to be helpful to write down. So my x value is -1 for my point. My y value is 3. And again, my radius is square root of 10. Okay. And so again, with these, a couple ways we could think of this. Again, if this is my theta angle in my triangle, for sine, I can think opposite over hypotenuse. And opposite over hypotenuse would be 3 over square root of 10. And you don't have to do this next step, but if you did, rationalize that denominator, that would be 3 square root of 10 over 10. Again, not necessary to do that for the test. Again, another way to find it is we kind of gave separate letters to each of these ratios too, kind of in this situation. So y over r, again, that always is going to tie in with my opposite over hypotenuse. Cosine x over r, right? Because again, we said too that cosine ties in with my x value. So cosine x over r, so my x value is -1. My hypotenuse is, or my radius is 10. And then again, you don't have to do this next step, but if you wanted to rationalize, that'd be negative square root of 10 over 10. And then tangent, y over x, right? We said that too. So y over x, 3 over -1 would just equal -3. So that's finding all those trig functions. And then again, the reciprocal ones are just flipping them around. So cosecant would be this flipped, square root of 10 over 3. Secant would be cosine flipped, so that'd be square root of 10 over -1, or just negative square root 10. And then cotangent, -1 over 3. All right. So there is finding all that stuff about that triangle. Actually, no. I forgot my angles. Okay, so then finding my reference angle here. Again, so what I want to think about is finding that, and again, there's a rule here. Positive ratio. When I'm finding my reference angle, this angle in the triangle, I can only use my positive ratio. And again, something that can help with that too is you remember all students take trig, or all students take calculus. That's more like it. But yeah, so this is telling us what trig functions are positive or result in a positive ratio in particular quadrants. So this quadrant, at this point being in quadrant 2, is telling me my sine is my positive one, and that is here, right? That's sine squared 3 over 10. That's my positive ratio. The other ones are negative, so I can't use those. So to be able to find this, I'm kind of skipping some steps here, but it ends up being inverse sine of this ratio, right? Kind of following the same steps that I did up here. I don't know the angle, I know the ratio, I know the trig function, so you'd almost have to like cancel that out, do the inverse with that, right? So inverse sine of 3 over square root of 10. And when we do that, you see I get 71.6. So we'll stick with rounding to the nearest tenth. 71.6 degrees. Okay, that means this angle in the triangle is 71.6 degrees. Okay, and again, that looks pretty accurate, right? It's definitely acute, but it's definitely a pretty big acute angle. Okay. And then lastly, my last part of this, I need to figure out, okay, how big is this original theta angle, right? Kind of from the initial side to that. And a couple ways you could do that, okay? We know that kind of these two added together, my reference angle plus my theta angle would equal 180, or a half rotation. So what I can do to find theta would be 180 minus 71.6, right? And if I did that, that would give me about 108. So 108.4, sorry, I messed up on that, would be the measure of this, okay? Last two problems. Okay, number 12. For the angle 3 pi over 2, find all six trig functions, or state that the expression is undefined. Show theta on your diagram. Okay, good. So 3 pi over 2, again, so we have our initial side, graphing 3 pi over 2. Again, if you forget, you got your reference, or your unit circle. 3 pi over 2 is down here. So that's going from your initial side, kind of a 3/4 rotation around my circle to the bottom of the y-axis there. So that would be kind of what it looks like. That would be theta, showing theta on the diagram. And we don't have to worry about theta prime or my reference angle because I can't go an acute angle distance back to my x-axis because this is a quadrantal angle. Okay, so what we have to know about this, right, is a couple things. Again, to get my six trig functions, I need to know an x, need to know a y, and I need to know a radius. Okay. And it doesn't specify any information. It doesn't tell us where like particular points are, okay? So again, what I can use, kind of just like on my unit circle, right? My unit circle is a circle with a radius of 1. We know that because of the coordinates of these other quadrantal points, okay? And we specify here too that a 3 pi over 2 angle has the coordinates of 0, -1. And so we're going to use that. That's the coordinates of this point, 0, -1, okay? And so with that in mind, right, that gives me an x and a y value of 0 and -1. But then it also gives me a radius, because think about this. If this was like, again, another circle, to go from the middle to 0.0, -1, this would have to be a circle with a radius of 1, because again, it's 1 unit away from the middle, and so my radius is 1. And again, that's always going to be my default radius when it doesn't specify a different point. Okay. So now again, now that I have x, y, and r, I have all the information I need to fill in these. And again, remembering our ratios, y over r, x over r, y over x, kind of again corresponding with all the original ones, opposite over hypotenuse, and etc. I can fill this in. Okay, so y over r, -1 over 1, or -1. Cosine, 0 over 1, which is 0. Tangent, -1 over 0. This is, remember, this is a big one. Can't do that. Cannot have 0 in the denominator. So we see that as undef or undefined, right? That's kind of what we're saying up there too. Undefined. Can't divide by 0. And then again, for my other 3 reciprocals, I take those and I flip them. So 1 over -1 still equals -1. 1 over 0, now when I flip that, now that's undefined too. But then cotangent becomes okay because that 0 moves to the top. 0 over -1 is still just 0. Very good. All right, last one. So if cosine of theta is -2/3, so it's giving me one of my trig functions. I have to find the other 5, right? So if cosine is this and theta angle is between 180 and 270, find the other 5 trig ratios. Okay, you don't need to draw the triangle, but the graph is there for you if you need it. Okay, so let's just think about this for a second. What do we know? We know that the cosine of this equals -2 over 3. And what else do we know? We know that it's between 180 and 270, my theta angle. Okay, so that's kind of cluing me into where my terminal side ends up. Okay. So a couple ways you can go about this. Again, if you're drawing it on your graph, kind of you have to think about like, okay, if your theta angle is somewhere, right, in your third quadrant, you can kind of draw this and kind of sketch this out. What else you can do too is just even thinking just about your ratio. Okay, cosine is always going to equal x over r, right? So when we have this, right, I know that x is -2 and r is 3. Just from this, I know 2 of my 3 values that I need, okay? And again, you might be wondering, well, how do you know the 2 is negative and not the 3? And the radius is always positive. So let's just do a quick sketch of that, okay? Because think about this too, a 180 to 270. So where on my graph is that? Again, you think about a 180-degree angle, 270-degree angle. So that's cluing you into the fact that it's in quadrant 3. Okay, so quadrant 3. So why is that important? That's important for a couple reasons. One, when I'm sketching this, I know where to draw it. But it's also important because it tells me about my coordinates, right? In quadrant 3, both my x and my y values are negative, okay? So I know that my y value has to be negative something. So using that, okay, let's just do a little sketch of what I have. Again, this part's not necessary on the test, right? So I know this point is at -2 comma something, and I know it's negative something, but I don't know much else. So you do that, right? Kind of sketching this, -2 and 3. I don't know this side, okay? But again, think about this situation too. I know 2 sides of a triangle, and I need to know the third side. So what I can do here is bring in my Pythagorean theorem, right? A squared plus b squared equals c squared, right? So right now I know one of my short sides, and I know my hypotenuse. So I can substitute those values in here. So -2 squared is 4, 3 squared is 9, okay? Subtract 4, b squared is 5. So b equals, now here's the tricky part, okay? Typically, when we solve these, like we did on the first page or two when we did Pythagorean theorem, we kind of excluded my negative answer because typically with side lengths of triangles, they're not going to be negative. But when we think about the context of a graph, we do include the negative answer sometimes. And we're definitely going to include it here. Why? Because I know that my y coordinate has to be negative because that's the only way it would be in quadrant 3 is if it was negative. And so you remember too, when if I said 2 squared could equal 4, but -2 squared could also equal 4, right? So there's 2 answers that you could get. Like if you took the square root of 4, you could say it would equal 2 or -2, right? And same with this, right? This would be positive or negative square root of 5, but I know because it's in quadrant 3 that it's actually going to be negative 5. So that's why it's crucial to know your quadrant, know your signs first before you do this, just because you are going to know ahead of time, like, okay, I know it's going to be the negative version of that answer in this case. Okay. Or like if it was in quadrant 1, you know that it had to be positive, right? Okay, so negative square root of 5 is my b value, and again, that corresponds with my y coordinate of my point, right? And so that answers this question. That's at negative square root of 5, okay? That's also the length of the side of this triangle. And so, finishing this up, we can find the other 5 trig ratios now that I know all 3 values. So I can do, again, sine y over r, so that would be negative square root of 5 over 3. Cosine is negative 2 over 3. Tangent is y over x, so negative square root of 5 over negative 2. Again, negative over negative is a positive, so that'll just square root of 5 over 2. And then you flip them all around, finishing it out. It's 3 over negative square root of 5. Again, rationalizing that denominator would mean it becomes 3 times the square root of 5 over negative 5, or with the negative up top too, doesn't matter. Secant would be 3 over negative 2, and then cotangent would be 2 over square root of 5. Or again, rationalizing that denominator to square root of 5 over 5. Okay. I love it. Great work, guys. Thanks for watching.